limiting reagents. Let's see one real example like H2 plus Cl2 when reacts and gives two molecules of HCl. It's a balanced chemical equation related to formation of HCl from combination of hydrogen and chlorine. From the given equation, on the basis of mass, we can say 2 into 1, that is 2 gram of hydrogen when combined with 2 into 35.5, because chlorine has atomic mass 35.5 gram of Cl2 gives 2 into 36.5 gram of HCl. Quantitative relationship between reactants and product is given here, that is 2 gram of hydrogen reacts with 2 into 35.5 gram of chlorine and gives 2 into 36.5 gram of HCl. So what are limiting reagents? Here 2 gram of dihydrogen completely reacts with 2 into 35.5 gram of chlorine completely. If we use dihydrogen in excess in place of 2 gram, 4 gram of dihydrogen is used. In a balanced chemical reaction, the required amount of dihydrogen is just 2 gram to give 2 into 36.5 gram of HCl. But if hydrogen is used in excess while the chlorine remains the same, that is 2 into 35.5 gram, then what will be the product? Product formed will be 2 into 36.5 gram only, and 2 gram of hydrogen will left. It will left in the container. Only 2 gram of hydrogen will be used, and total chlorine will be used in the reaction, that is it will be consumed. It will be consumed completely. So what is the limiting reagent? In a balanced chemical reaction, the reacting species that is consumed completely is called the limiting reagent of that particular reaction. The limiting reagent for the same reaction may change, may vary. It depends on the amount used. Here in this balanced equation, only 2 gram of hydrogen is used. Rest 2 gram will left. No need will be here, because overall the required amount of the chlorine is 2 into 35.5 gram. So this amount will control the formation of product, that is the production of product will be limited by dichlorine. So another definition of limiting reagent is the reacting species that limited the product formation is called limiting reagent in that reaction. So here two definition, in two ways we can explain about the limiting reagent. The reacting species that is consumed completely in a chemical reaction is called limiting reagent. Another definition, the reacting species that limited the production of product formation or controlled the product formation or controlled or limited the quantity of the product formation is called the limiting reagent. So here in this equation, if excess of the hydrogen is used, then limiting reagent will be chlorine. Now in the same equation, if we change the amount between the reacting species, since we know balance chemical change shows 2 gram of hydrogen 2 into 35.5 gram of chlorine gives 2 into 36.5 gram of HCl. So from the balance equation, now we will use here 4 into 35.5 gram of chlorine in place of 2 into 35.5. We will use chlorine in excess, and here 2 gram will be as such as in the case of balance equation. So what will be the product formation? It will be again 2 into 36.5 gram of HCl. Why? Because 2 gram of hydrogen will completely react with 2 into 35.5 gram of chlorine, and rest 2 into 35.5 gram of chlorine will be left in the container. So which between the two reacting species will control the product formation, will limit the product formation? It is dihydrogen. So the same equation, but on the basis of the amount of the reacting species, limiting reagents get changed. In this equation now, hydrogen behaves as limiting reagent. So what is the definition? I repeat again. The reacting species that completely consumed in a chemical reaction is called limiting reagent of that reaction. Let's see another example. Again, formation of ammonia by Haber method. N2 plus N2 plus CH2 and formation of ammonia. Here the balance equation represents 2 into 14, that is 28 gram of nitrogen combines with 3 into 2, that is 6 gram of hydrogen, and gives 2 into 17, that is 34 gram of ammonia. It's a balanced chemical equation, and here stoichiometric coefficients are given. If in this balance equation we use 4 gram of hydrogen in place of 6, so overall hydrogen will be consumed here. The required amount of hydrogen is 6 gram, but here only 4 gram of hydrogen is present. So hydrogen will be consumed completely, and the product formed here will not be the same as given in balanced chemical reaction, since amount of amount of reactant is less as per the required by balanced chemical change. So amount of the product formation will also be less as compared to the balanced chemical equation. So it's clear from the given amount, first thing, that dihydrogen will be the limiting reagent here, because it will control the amount of the product formed, and the amount of product will be less as compared to the balanced chemical equation, because here the limiting reagent has less amount used as compared to in the case of balanced chemical change. The same situation if we change here, if in place of 28 gram we use just 14 gram of nitrogen, and hydrogen value remains same 6 gram of hydrogen, then since the value of nitrogen becomes less than the balanced chemical change, so here now dinitrogen will behave as limiting reagent, and again the product formed will be less than the balanced chemical change. So this is all about related to limiting reagents. It's also based on the quantitative analysis of the reacting species, that is the amount used. So we have discussed about the stoichiometric coefficients in the previous lecture and limiting reagents in this lecture, and this is all about for the limiting reagents. Thank you.